organization about freedom of choice, if you want to have a baby or not. FOCA has nothing related to this. Either this, we are not related to nothing with the Catholics. A FOCA is this. This is a FOCA in Spain, so please never say to a girl, you look like a FOCA, because it's a very bad word. So if you go with this kind of t-shirt to your girlfriend, or it's a very bad idea if she is wearing the t-shirt in Spain, because people are going to say, ah, she's a FOCA. No, it's a very bad idea. I'm going to talk about what is FOCA and what's the story of FOCA, because FOCA is a tool that we developed 3 years ago, and we've been working on it since that moment. In the beginning, FOCA was only this, a tool that we use internally to extract metadata and clean up the documents, because we are working on a company focus on security, and it's a very bad idea if you are sending documents with your internal user, internal servers, and so on. So we created this tool internally, which is called Meta Extractor. From this tool, we started to work in the new version. The idea of the name is just a joke, because the guy who was in charge of coding the tool was called Francisco Oca. So the first letter of his name is F, and the surname is Oca, so we said, okay, the tool is going to be named FOCA. That's the joke. At the beginning, FOCA was only focused on metadata, and we were working on extracting as much information as we could from all the documents. So we searched for the metadata, which is special fields that you can add manually to your document to index the information or to discover a special document which is related to a project or something like that. I know that you sometimes miss your files in your hard drive, and you are wasting your time for more than 1 hour searching for a file in your laptop, saying, my document is here, I know it. How many of you have been searching for documents in your laptop many times, wasting your time? Wow. Due to this problem, they created the metadata, which is a very good idea. And we call it metadata because you can use the tool to modify, to add the information, and so on. For instance, if you are working in a Word document, you can go to Tools and manage the metadata. The second information is the hidden information, hidden data, which is not nothing special. It's not something special. It's just metadata, but not for the user. It's for the application. It's metadata about what printer did you use to configure the web page, which template did you use to configure the documents, and so on. It's hidden information because you don't have any option in the application to manipulate this data. So it's in the document, but you cannot see what is in the document, and you cannot modify that information. And the last one is the lost data, which is information which is in documents by mistake. For instance, an internal link to an internal server, or a picture with embedded data, or because you copy part of the document from another document, and some of the fonts are in the same color of the background, or that kind of human errors. Well, FOCA extracting that information is very important in some cases. We call it metadata risks. The first one is to discover secret relationships between companies. It's quite nice if you discover that a government is related to some special companies. If you want to have fun, you only have to download the HB Getty emails with all the attachments, documents, and extract the information, and you can see who was managing the relationship between HB Getty and the government, US government. It's quite nice. It's illegal, but in some countries. Well, of course, with companies and government, there are special cases. In Spain, we got a lot of big scandals with this, because sometimes the government is publishing a document with conditions for a contract, and then a lot of companies are applying for the contract, and one of them is selected. And in Spain, we got a lot of cases in which the company selected was the company which created the conditions, which is very, very bad. Of course, to discover piracy, if you are publishing documents in your website which have been created with CorelDRAW and you don't have CorelDRAW, that's very bad for you. If you are working with Linux machines and OpenOffice and so on, and you are saying publicly that you are using OpenOffice and you are publishing your information in Microsoft doc file, it's bad for your reputation, even, especially if you are a Linux supporter. And of course, can be used for special attacks. One of them is for social engineering attacks. You get a lot of information from the internal company, and you can do a lot of tricks. One of them is quite nice, and one of the people who was using FOCA told us the story. And the last one, of course, to prepare a targeting malware attack. The story of metadata started in 2003 with the Microsoft Word document of Tony Blair, in which Tony Blair said publicly nobody from his team had been manipulating a document about the Iraq work, and in the end, in the document, they were working on it, 10 people, 2 of them take it to home in a floppy disk, and well, it was a very big scandal, and after that moment, everybody is cleaning up the metadata from documents. It is true. I hope. Well, with targeting marking, the idea is quite simple. The idea is that you have to discover an internal victim, a user which is connected to the internal network, and that user is using an unsecure computer or a legacy machine or something like that. Then you can create a piece of malware that is going to send to that user in a pen drive that very happy moment in which you go out from the car and say, oh my God, a pen drive of 4 gigabytes, and you take it and go to your laptop and plug it in your computer because maybe there is porn pictures in it, and it's very important. So you can, if you discover this guy, and this guy is working with an internal server which is not public on the internet, but it's in the internal network, then you can copy the malware to this server, and of course, all the users working with it can be infected. The idea of doing this with FOCA was very easy. In the first version of FOCA in 2008, that we did is just download all the public documents, extract all the metadata. In this example, they are documents from the Missile Defense Agency of the Army, the US Army. And as you can see, with only 125 documents, you can discover 106 users, 116 folders, printers, and so on. And with the previous version of FOCA, with FOCA 1, you can construct the internal network, as you can see. And the idea is that you can discover, for instance, that this guy, which is called Norm Hensley, which has a LinkedIn profile with pictures, with information about the village in which he is living and where he is working. He's working for the government, of course. You can discover that Norm Hensley is working on a Windows XP machines and is working with these 2 internal servers. So you can, you know that if Norm Hensley plug the pen drive in the computer, you get access to that internal servers. And of course, with the previous versions of FOCA, you can discover also the internal servers and all the users working in them. So this is an idea to create a targeting attack. For social engineering, there is a very good trick. The idea is that if you got a webmaster which is in charge of the website and is publishing documents, you can download a document which is already published, extract the metadata, discover who was the author of this document, and send the document to the webmaster impersonating the email address, but saying, OK, I did minor changes. Please republish this new version of the document. And of course, the document is going to have a very good Trojan, which is good for everybody. And if the security policy is not taking care about this and the webmaster is publishing the document, then everything is done. This is an example with a Spanish website, and we did it the same. Well, of course, in the case of Anonymous, the story started with metadata. Probably you remember that the Anonymous group was was in a campaign against all the people who were against WikiLeaks, and one of the guys published a press note in PDF, and in the PDF he forgot to clean up the document, and his name was in there. So okay, after that it was very easy to search for information. If you change the data before the day, you can discover that he was a designer. He tried to delete all the information from his personal website, but also in the WHOIS, but in his personal website, he forgot to remove the metadata in the HTML code, the meta tags. And it was possible to discover that his alias was Tapan, and searching for the alias, which is Tapan, it was possible to discover all the information about this guy, again, using metadata, and of course the story ended up with him arrested. Well, of course, not only in public documents, we got GPS information in picture. That is a joke. It's a drug smuggler publishing a picture with iPhone with the GPS information, which is very bad. If you are moving drugs from a country to another country, don't publish picture with GPS information. It's not a good idea. And with the first version of FOCA, we were extracting metadata for all these kind of documents. Of course, Microsoft Office, OpenOffice, PDF, APS, graphics, and in the second version, we added some new documents. What can be found in a document just searching for metadata? Well, a lot of information related to the network security, like users, printers, information about the network. If you got a user working in a server, you can figure out that that user is in the ACL list. So if you got a big amount of files, you can construct the internal network with the ACLs, the IP address, the server names, and so on. Let's do some quick demo with single files. To do this, first one is, this is one of my favorites. This is a document published in Spain. It's in Spanish, because in Spanish it's better. And it's from the Senatic, which is the National Reference Center of Using Open Source Technology. National Reference Center of Using Open Source Technologies. And the document is 10 reasons for choosing open source software in the education. And okay, you only have to drag and drop the file to FOCA, and you can imagine what is going to happen. Extract the metadata, and of course the document had been created with Apple Keynote and Mac OS X, which are not open source at all. Maybe they were confused because the operating system letters. Maybe. And that one is one of my favorites. It's the Linux installation guide. Linux installation guide of one of the most famous Linux in Spain. There is a big region in the south of Spain with Linux installed in all the machines, because this Linux distribution had been pushed by the Spanish government. And you got the manual, the tutorial about how to install Linux with all the information and so on. And of course, you can drag and drop the Linux installation guide and extract the metadata. And of course, it has been written with Microsoft Word, which it's a very bad idea. Of course, for sure, they didn't buy the license of this Microsoft Word. And it's the version 3. Well, and the last one is just a picture about metadata, but it's a special picture. It's one of the pictures that you probably can use in our social network as your profile is this. If you are a computer engineer, this is a woman. And the story of this is that, as you can imagine, as you can see, it is cropped. And there are a lot of information in the white side. Pay attention to the white area. And it's cropped. Of course, the picture is full of metadata. And just drag and drop to FOCA, extract metadata. And in it, you can discover that is true. If you got an iPhone, women are more willing to have a relationship with you. And, of course, the information with all the GPS data and the full picture with the foot of the guy and the face of the guy reflect on the TV screen, which is a fair, well, ocean. Well, the problem is that if you are extracting metadata from one file, okay, you can discover something weird on the file. But if we are looking after all the documents published in a website, like in this example from the FBI, you can see we got almost 5,000 documents published on the internet, just indexed by Google. So if we were able to extract only one data from the internal network from each file, how many data from the internal network will be able to discover? A lot of data. Well, the question is, are they cleaned? Well, for sure not. And if possible to extract just the internal user, just Googling. In this example, just using the title field in the PDF documents, you can discover the internal users of the FBI. Drevnia, Callaway, the Washington, and the only thing that you have to do is just searching for documents of PDF, which in the title is documents. This is just because they are publishing the PDF document, creating the PDF document using a virtual printer. And in some of the virtual printers, if you don't have set up any title, are going to use the path from which you are printing the document. And of course, if you are working on your personal desktop, you got your internal route. Well, to do this in an automatic way, we created FOCA version 1, which was published in 2008. And the idea is just search for all the public documents in Google and Bing, download it, all of them, extracting all the metadata, clustered information, trying to discover which file have been created from the same computer, and printed all the information of the network. We are going to do this with the DISA, which is the Defense Information System Agency of the US government. Let's create a new project, disa.mil, disa.mil, and now a folder, event, troopers 2000, this. Okay, so we can't just click on search all documents. As you can see, you can select what kind of documents you want to download from 3 different search engines. Right now, Google, Bing, and Exalite. Just click on it, search, whoop, or just drag and drop the files. Whoop. In this example, I'm analyzing only 100 files. Only 100 files. Extract all metadata. They are publishing almost 1,000, but I did it with only 100 files, and I selected the smallest files. As you can see, only 7 keys, 12, and so on. And of course, you can extract the internal users from the government, and folders to local folders in the computer, printers to internal servers, internal IP address, and so on. Tigris, interesting name. And software, email address, and so on. And just clicking on Analyze Metadata, FOCA is working, FOCA is working. FOCA is working. FOCA is working. Well, as you can see, FOCA is trying to collect collect as much information right now from the document, and also is doing queries to the internet to resolve DNS name, to trying to resolve the IP address of an internal name, and so on. And in the end, after 1 minute, more or less, FOCA will finish. This is the moment that you can use to play Mind Searcher. Perfect. So this is not a bomb, this is a bomb, this is not a bomb. Bomb, 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 bomb. FOCA is working. Hey, for sure you do the same in your work. Probably a bomb here, but not here. Well, FOCA is trying to collect all the information, and in each computer you can analyze which document had been used to construct this node in the tree, and the users. Administrator, Angela no, and so on. And the servers, FOCA is collecting also the internal servers and saying, okay, this server, in this server is working Troy Johnson's. In this, another server is creating the node. Oop. This is the IP address, of course. As you can see, FOCA discovered this internal IP address that can drive you to print all the network segment. And if FOCA is telling you from which document, from which part of the tool discovered this data. Well, finished. OK, that's done. As you can see, there are people using Macintosh, people using legacy computer with Microsoft Office 2000, Windows 2000, NT4, and these guys are creating a lot of documents using the internal printer and so on. OK, this information is published on the internet. We just download the file and read the data, but in a different way. But it's public. We are not doing anything illegal, just downloading document and reading. That's all. Well, this was the first version of FOCA, but in the end, when you are working as a pen tester, you got a problem that you only have 3 days to analyze 200 IP addresses. And you say, how many days? Only 2 days to analyze 200 IP addresses. So sometimes you need to be a superhero and work as much hard as you can. This is me as Batman, and Fantastic Four. I'm going to show you a video about why we are superheroes. This is a video from CSI. No, it's not. Yes, it's from CSI New York. And at one moment, a hacker is going to discover the internal IP address, and that's the way she did it.
For weeks, I've been investigating the Cabby Killer murders with a certain morbid fascination.
This is in real time.
I'll create a GUI interface using Visual Basic. See if I can track an IP address.
Have you listened? I'm going to create an interface in Visual Basic to discover the IP address. Incredible. Well, sometimes you don't need to be a superhero. This is one of my favorite websites in the US government. It's a public FTP, an unsecure FTP, in which is unsecurity, and the only security feature is any other use is unauthorized. That's the security protection. You just need to click on here and get inside. People don't trust me when I tell this story, but it's true. And of course, it's created for Netscape 4 and Internet Explorer 5. It's amazing. But you only need to click on it. Well, this is illegal because we are clicking in something. Come on. It's not Internet Explorer 5. Don't worry. Let's copy the direct access. no, it's opening a folder. So you also need to shut off the pop-up blocker. So as you can see, there are several directories, one of outgoing, and as you can see, this, for instance, this directory was created on 29th of March, so yesterday. So, and you only have to click on it to discover the information about the MIU project, whatever it was. This is a security protection in the US government. Incredible. Well, so another of the features that, which is incredible with metadata and hidden information is the lost data. One of my favorite examples of lost data is with this company. This company, Syngress, is selling books on the internet, and you can buy a copy in a printed copy or an ebook copy. The idea is that if you buy the printed copy, in the book you have a special code which allows you to download the ebook. So you got the printed copy and the ebook. Of course, if you go to Amazon and search for the same book, Virtualization for Security, first of all, it's cheaper buy the book on Amazon than in the publishing company, but there is a special feature which is look inside. You just click on look inside, first page it, and the code. That's the kind of lost data in public documents. Take care of it. Well, to do this, to improve the mechanism of analyzing network, we created the 2.5 version, and the idea is that we move the focus from metadata to network information, and we add a recursive algorithm which is trying to discover as much internal servers as it can, and it's just doing an information gathering process and constructed the internal network. The idea of this is just a panel like this in which you can select which modules you want to use. In this example, just the web searcher, which is going to search just for links on Google, Bing, and so on. The DNS search, which is going to connect to the internal DNS and trying to discover the internal network with the PTR scan, is going to analyze the service records, is going to analyze the mail servers, the well-known records, and so on. The transfer zone, a dictionary attack, the Google sets prediction. The idea is just that after every hostname discovered, we are going to send the hostname to Google set service and retrieve a list of 15 words related to that name. For instance, if we discover Tigris, maybe it's the name of our rival, and there is another rival in the internal network. So with the Google sets, we are going to discover all these related servers. And of course, the IPVIN service, which allows you to discover new host names in the same IP, and the PTR scanning that discover the internal PTR records. So the idea is that also we added a new search engine, which is Exalit, because not all the web searchers are working in the same way. For instance, in this example with the White House, if we use only Google to discover documents, if you do only Google hacking, you are going to retrieve 332 documents. If we do the same with Bing, you are going to retrieve 375 documents, more than with Google. This is due that Google is not implementing correctly the file type parameter. Google is searching only for the extension. It's not implementing correctly the file type. If you got a program, a PHP program, which is retrieving PDF documents, for Google is a PHP document, not a PDF. And using Exalit, we discovered 2,312 documents, a big amount of documents. If you do only Google hacking or Bing hacking, you are missing a lot of documents, of course, with a lot of information. This is just because this web searcher is less friendly. So most of the web searchers, the spiders, when they found a form, they stop. But some of the web engines are saying, OK, this is a very common form just to click on the next page, so we are going to click on the form. Okay, this is the idea. And of course, using the three of them, you discover almost 3,000 documents. So from the beginning to the end, there are a lot of information that can be analyzed. Well, we also had a problem with the huge domain. If you are analyzing the army.mil site, there are 3 million of URLs, and only searching for doc files is impossible to download all of them, because Google is only going to give to you 1,000 links. So you cannot download all the files. So we created a special option in FOCA that allows you to find documents from each host name. So the idea is that you can discover previously the internal network, and then from each host name trying to discover the documents. In this example, as you can see, this is the structure of the Norwegian government. And at that moment, you can say, OK, I want only documents from this host name. And you got the option also here. Well, the DNS search, and so on. And the idea of the algorithm is this. At the beginning, with FOCA 1, when we found a URL like this, we download the file and extract the metadata and print the internal network, as you previously have seen in the first demo. Is this true? Well, right now, we said, OK, this is an HTTP server. So let's get the banner HTTP to recognize the software. Domain.com is a domain. So let's search for the well-known records of this domain. Sub.domain.com is a subdomain. Then let's search for the well-known records. All the internal servers that we weren't able to discover the internal IP address, let's try to discover it, asking the internal DNS about all the non-verified internal server with the new domains. Of course, Apple.1 is a host name. Let's try a DNS prediction, because Apple 1, probably there is an Apple 2 or an Apple 3 or an Apple 4 and so on. Let's try Google sets with the Apple 1 word. So let's send the Apple 1 word to Google set. Let's retrieve 15 related words, and let's try the 15 related words with all of the domains that we previously discovered. Also, let's resolve the IP address. Let's get the certificate of the HTTPS connection against the IP address. Search for all the domains that appear in the digital certificates, because digital certificates can be issued for various host names. Let's get the banner of the IP address, HTTP, but only for the IP address, not for the host name. Let's use Bing for discover all the domains sharing the same IP address. Let's repeat the whole process for new IP address. Let's connect to the internal DNS, to one or to all of them, because in most of the cases, the internal DNS are not in the same level of configuration, so you can discover different things from internal server. Let's perform a PTR scan searching for internal servers. For new IP discovered, try Vin IP again. Let's probably assume that Chema is a username, because this is the way that in Apache you can share the home of a user, the user home. Of course, //Chema and /Chema dir are path. Let's try the directory listing in all the path. Let's search for unsecured HTTP method in all the path that we were able to discover. Let's fingerprint the software in the server using the error messages of 404 and the application errors. Let's try the common names against all the internal DNS. Let's try the zone transfer search. Let's search for any URL indexed by web engine related to the host name, not only the documents, just HTML URLs, PHP URLs, JSP URLs, all kind of URLs. And then let's try it again, start again, and then download the file, extract the metadata, the hidden information, lost data, sort all this in a nicely way, and start it again for new IP address. And you only have to click on search. FOCA does the rest for you. Yeah? So we don't have time to do the pen testing. So, well, the idea is that with FOCA, let's start new project. Hey. Let's start a new project from the beginning. Hey, only one FOCA. New project. This .mil, this .mil. Troopers. I'm here. This .mil. Okay. You only create the project. Just from the beginning, just clicking on search, all the URLs are going to be analyzed. So just clicking on search, and all the URLs are going to be analyzed. But from the search panel, you click on start, and FOCA is going to search for URLs, search for well-known DNS record. Let's test the transfer zone, the zone transfer of the DNS. Let's test all these well-known names. Let's try the Google sets, the IPv, and the PTR scan. All the information is going to be short in different panels. This one is the tree of the IP address, in which you can see the clients and the servers. Then the domains, which is a tree structure of all the domains discovered, the IP address, and roles. So if FOCA discover an HTTP server, you are going to have the HTTP server here. If FOCA discover an HTTPS server, it is going to stay here, mail, DNS, and so on. And of course, if any vulnerability is discovered, like this, FOCA is going to add the server with the vulnerability to this tree. So if you are analyzing a 1,000 servers domain, you only have to click on FOCA and wait until the vulnerabilities appear here, because in a big domain, a domain that big probably always have information about it. Well, HTTP server, FOCA is discovering information. And as you can see, FOCA is analyzing all the domains. In this example, this .mil is the main domain. FOCA fingerprint the software, searching for the, fingerprint the software. As you can see, SAN1, web server 6.1. FOCA is analyzing also the HTML title, because we discovered a lot of crappy things in the title. And for each domain, you can discover the information. FOCA is analyzing the files, the folders, and if an unsecure method appears on one path, you can have the information here. In this example is the trace method. There is a special attack for trace method. And FOCA is performing all this. Well, FOCA can be working right now for more or less 6 hours, discovering and collecting information from these sites, the tree, the roles, and vulnerabilities. And for instance, in this side, there is a directory listing vulnerability, so you can browse this path to discover the directory listing. Well, an unsecure method, server with unsecure method, some of them with trace, another one for sure with delete, and so on. Well, I did it with DISA for 1 day, and well, FOCA is now loading the project. It's a big project with almost 2,000 servers, internal servers, more than 10,000 domains, and of course, more than 40,000 URLs analyzed, and a lot of information on it. It's now working. Let's FOCA working, and let's continue, and we'll see in the end how it looks like. Well, more things in FOCA 2.5. We added a fingerprinting option. By default, when you download FOCA, all the URL analysis is by default. If you don't want to add the fingerprinting option, you can unset the option on the panel. And well, things that FOCA is doing is analyzing the unsecure method, searching for the options, just asking for options in all the paths, searching for put, delete, that can drive you to upload a file on the servers. For instance, this is an example with Apple. Apple has a server in which they are publishing documents, and the put method is available. Also, FOCA allows you to sort the target, so it's analyzing all this kind of technology, which is the technology that if you are doing a pen testing are going to search for and trying to discover information. Well, also we added integration with Shodan. We were in contact with John, and John created a special key for FOCA. And right now, just clicking on, once you finish to discover all the internal IP address or the public IP address, you can click on one button in FOCA, and FOCA is going to send all the IP address discovered to Shodan and retrieve all the information that appear in the Shodan database. So let's see this first of all with the project. It finished. Let's see the network data. This is the tree. There are 1,983 servers. As you can see, some of them are public, some of them are automatic names, which is the name that they are using to manage the IP address. As you can see, we cannot discover any software related to it because we only can discover this server using a PTR scanning. So the idea is that we cannot contact to that internal server, but we know that this server is in the network because the internal DNS responds to this IP address with a PTR record. A lot of them, and of course, intranet test servers. Servers that they are using to develop new project or to test something related to security. Some of them, a lot of tests, VPN, intranet, and so on. Well, a lot of information that if you are working in a pen testing for sure is going to be very useful. Information about the domains, a big query. Vulnerabilities. There are backups, there are directory listing, there are a lot of data. But it's illegal, so we're not going to do anything more. Well, how it works right now, secure methods, backups, directory listing. The idea is that you only have to click on the search, and that's all. FOCA does the rest of the work. Well, it's a very big project. I'm going to close this project and open a new FOCA to do it, a demo with the White House, a quick demo. Open it, FOCA. Come on. Kill the memory. FOCA is working. Believe me. It's trying to destroy all the memory. All the process. Well, let's finish, and then we are going to the demo. In the pro version, we added this utility. It's just a fuzzing option. It's not like Witco. I would like to have Witco in FOCA, but it's not Witco. It's just an option that is useful for us. Also, it's searching for the dot listing vulnerability. I don't know why this is happening, but there are a lot of places in the internet that allows you to search the directory listing, just searching for .listing application, and the idea is that due to this program is called .listing, for Google is an extension, so you can search for extension listing and discover a lot of places that having this. For instance, NASA, you can download a lot of files from NASA, and so on. And we added special tools like the DNS Cache Snooping tool, which allows you to discover the internal software or the internal user analyzing the DNS cache. The idea is quite simple. It's just to connect to the internal server, set up the query as no recurse, and ask for a URL. So if the internal DNS knows the IP address, it's going to respond with the IP address, and that means that previously someone has asked for the same URL. So doing this, you can discover, of course, people with internal habits. So people who is not working is in Facebook, but also internal software. For instance, the people who is using Google Talk is connecting against the Google Talk server. People who is using Java is connecting against the Java update servers. People who is using Microsoft machine is connecting against the update machines, and so on. So we created a special file with software which is vulnerable to evil grade attacks. And the idea is that you can search for that vulnerable places. Also, you can, using this technique, you can discover the internal antivirus, because your internal antivirus is connecting against the antivirus update server. So you can create a targeting malware which bypasses your internal antivirus. And if you are able to discover to which website is connecting every day the same person because he loves phishing, for instance, you can hack the phishing and then infect the user. That's the idea of DNS snooping techniques. And all the things that you can do with this. And in the progression, we got a special module, which is only to construct some reports. It's not a very big module, but allows you to export all the documents with internal data and create some graphics and so on. Let's finish the demo with FOCA. FOCA, perfect. FOCA finished. And now, let's do the demo with the White House. The idea is quite simple. You just create a new project, whitehouse.gov, whitehouse.gov. Let's use this IP folder, by instance. And then just clicking on Search All, we are going to use, we are going to search only for PDF documents, because right now the White House is publishing documents only on PDF, and let's use whatever. Let's search. Now FOCA search for the URLs, and at the same time, all the URLs are going to be analyzed, as you can see, and of course, the whole part of the process. So as you can see, for instance, we got an unsecure method, a key of put, and if you want to upload a file, you can use a special option, which is upload file, select your personal shell, and so on. Well, that's all. I don't want to do anything. And of course, you got all the information in vulnerabilities, in roles, that allow you to classify, to sort, all the information. I'm going to stop. I want to visit the States more times. And that's all. I'm not going to do a demo of DNS Cache Snooping. I forgot it to take off the presentation. And remember, FOCA is only a fingerprinting tool. It's not a hacking tool. It's just to collect information from public sources. So everything is public. The idea is that it has a recursive algorithm which is working and working and working and analyzing all the information at the same way that you probably do in your work. When you are working as a pen tester, you are doing the same. The idea is that FOCA does automatically for you. There's not a Linux version. I'm sorry. FOCA runs only on Windows. There are people who run FOCA on Linux in a wine way, but we are not sure if it is working very well. There is an online version of FOCA, which is just for uploading documents and analyze metadata. All the documents are in our servers. You can trust on us. We are not going to read in your documents, but if not, don't do that. And there's an open source tool for cleaning metadata in OpenOffice document because there is not a tool in OpenOffice to clean up metadata and hidden information. This is OO Metastructure, which is public. And this is a commercial product that we created using the idea of FOCA, and it's a plugin for IIS. And the idea is that once a document is going to be downloaded, previously all the metadata, hidden information, and lost data is cleaned up on memory, and the user is retrieving a clean file. It's quite nice. And that's all. If you want to download FOCA, there is a version 2.61, which is fixing a problem with Google because Google did little changes on the web, so we need to create a fix, and it's 2.61. It's published from 2 days ago. And if you love FOCA and want the pro version, you can go to a training, an online training, and we are giving the FOCA Pro for anyone who attended the training. And if you got the FOCA version and you want an update because you got the FOCA Pro 2.5 and you want the 0.6 or whatever, well, just ask for the Pro version and that's all. And of course, you can buy a t-shirt if you want to be sexy like me. Sometimes you don't need even a t-shirt to be sexy, and that's all. And don't forget to visit Spain because I'm not from Argentina. And you can see the trophy that we got there in Madrid. And that's all. Thank you very much for attention.
Chema, thank you very much.
Welcome.
Other questions? Okay, no questions. Then we will take a very short break just to switch our speakers.
Perfect.
2 or 3 minutes.
Sometimes I feel I've got you. Run away, I've got you. Get away from the pain you drive into the hurt of me. The love we share seems to go nowhere, and I've lost my light. For I just and turn, I can sleep at night. Once I ran to you, now I run from you. This tainted love you've given